Hi everyone, I am A. Uma Maheshwari, Assistant Professor in KCS Kasinadar College of Arts and Science. In this video, we are going to see about t-TEST. The tea distribution was invented by W.S. Gossett, who was a statistician for an Irish brewery. He published this scholarly work under the pen name Student in 1908. Hence, the tea distribution is called student's tea distribution. T-TEST. What is t-TEST? The t-TEST tells you how significant the difference between groups are. There are three types of t-TEST. First one is the mean of a small sample and the mean of the population. Second is the means of two samples. Third is the means of paired observations. We have one problem in t-TEST. Before we are going to see the problem, we must know the sample concepts and test of significance. Sample concepts, definitions. Population. The whole information which comes under the purview of statistics information is called population. It is also called universe. Sample. A sample is a finite subset of the population. Sample size. The number of elements in the sample is called sample size. Small samples. If the number of elements in the sample is less than 30, then the sample is called a small sample. Parameters. Statistical constants like mean, mu, variance, sigma square, etc. computed from a population are called parameters of the population. It is denoted by theta. Sample statistics. Statistical constants like mean x bar, variance s square, etc. computed from a sample are called sample statistics. It is denoted by small alphabet t. Next, test of significance or hypothesis testing. Statistical hypothesis. In making statistical decisions, we make assumptions about populations involved. Such assumptions, which may be true or false, are called statistical hypothesis. Null hypothesis. This statement is usually a hypothesis of no difference and so is called null hypothesis. It is denoted by H0. Alternative hypothesis. Suppose the null hypothesis is false, then something else must be true. This is called an alternative hypothesis and is denoted by H1. Two-tailed test. If the alternative hypothesis is two-sided, then it is called a two-tailed test. One-tailed test. If the alternative hypothesis is one-sided, then it is called one-tailed test. Now let us go to the sum. The problem is a random sample of size 16 has 53 has mean. The sum of the squares of the deviations taken from mean is 150. Can this sample be regarded as taken from the population having 56 has mean? What is given in the sum is sample size n is 16. Sample mean x bar is 53. Sum of squares of deviation from mean. In symbol, summation x minus x bar whole square is 150. Population mean is 56. Here, sample size is small and we want to test the significant difference between sample mean and population mean. So, we apply t-TEST. We find sample standard deviation first. The formula is S equal to square root of summation x minus x bar whole square divided by n. Substitute the value in this formula, we get the S value 3.062. Then set up null hypothesis H0 mu equal to 56. That is, there is no significant difference between sample mean and population mean. Step 2. Alternative hypothesis H1 mu not equal to 56. That is, there is a significant difference between sample mean and population mean. Here, alternative hypothesis is two-sided, so we take two-tailed test. Next, under H0, the test statistic is t equal to x bar minus mu by s by square root of n minus 1. This is t-test formula. Substitute the value in this formula and simplifying, we get the t value is minus 3.7945. Modulus of t equal to 3.7945. Now, we find degrees of freedom. Degrees of freedom, new formula is n minus 1. So, we get nu equal to 15 degrees of freedom. The table value of t at 5% level is 2.131. Here, calculated value is greater than table value. So, our null hypothesis H0 is rejected at 5% level of significance. Hence, our conclusion is there is a significant difference between sample mean and population mean. Thank you.